Dear student, this is the third class on the chapter differential equation, and in this chapter we will focus on the following topics. Number one is solution of non-homogeneous differential equation, and in this case we will solve some non-homogeneous differential equation and then exact differential equation. This is the process and the methods with which we can uh, solve exact differential equation. So let us start. First of all, we are here to solve non-homogeneous equation, and these non-homogeneous equation can be first converted to or reduced to homogeneous equation, and then it can be solved. And here are see here in some homogeneous non-homogeneous in some non-homogeneous equation for which f and g are function of x and y can make homogeneous equation by the following substitutions. That is, you know that in case of homogeneous equation, dy by dx was ax plus by or cx plus dy etc. in this form. That is function of xy and in the denominator and in the numerator, and in the denominator it was again function of xy. But here see another constant are in addition with this term. So this type of equation are not homogeneous, these are non-homogeneous, and here is a problem. There is a problem to solve this problem, this differential equation there. And to solve this type of differential equation you need to first you need to reduce or convert it into a homogeneous equation. And if once it is converted into a homogeneous equation, then it will not very difficult to solve that differential equation. So let us start. Let us see that we can substitute by x is equal to capital X plus small h, and small y is equal to capital Y plus k. And in this case, h and k are two constants, and these h and k should be chosen appropriately or suitably. And the process or in which manner we can choose h and k are discussed in some after some lines. So just go through this now. For an example, let us we take a non-homogeneous equation in the form of dy by dx is equal to ax plus by plus c by fx plus gy plus d. And to solve this equation, first you need to substitute x and y in terms of capital X and then h and k. So since you have already substituted small x is equal to capital X plus h and y is equal to small y is equal to capital Y plus k, just substitute these values in this equation. So dy by dx is equal to first ax capital X plus ah, then by means b capital Y plus bk, and then this c is here. Similarly here fx plus fy plus g capital Y plus gk plus d, and just to write this equation as ax plus b capital Y then plus a h bk plus c, and then fx plus gy plus fh plus gk plus d. Okay, and now this equation and these in these two expressions, that is this expression and this expression, that is in the numerator and in the denominator, the value of h and k should be chosen in such a manner that the term except this x and capital Y, that means ax plus by, this term except this term, that means ah plus bk plus c is equal to 0. And in the similar way this term fh plus gk plus d should be 0. So we have to choose h and k in such a manner that these two constant terms becomes 0. And if it becomes 0, then you can write from equation this equation, that is equation number 3, that dy by dx is equal to ax plus by by fx plus gy. You know that this is a standard form of homogeneous equation, and this can also be written as a plus by by x by c plus gy by x. Capital X is taken a common term. So this equation has the form of a homogeneous equation which can be solved easily. And the values of h and k can be chosen, can be determined from these two equations. And using and but they have to follow a condition, that is ag minus bf not is equal to 0. That means determinant of a, b, f, g not equal to 0, and this should be checked before solving a non-homogeneous equation. So if we wish to convert a non-homogeneous equation to homogeneous equation and to solve it, then you have to first check whether this determinant is equal to 0 or not. If it is 0, then it is not possible to convert into your homogeneous equation. But if it is not is equal to 0, if the determinant has some finite value, then you can convert it into a homogeneous equation by the substitution of what that is written here. Small x is equal to x plus h, and then y is equal to y plus k. And after that, so let us here see here for some examples. So this is the process how to convert a non-homogeneous equation into homogeneous equation. So here are some examples. First one is solve the differential equation given below, that is dy by dx is equal to x plus y plus 3 by x minus 5 minus y. So this is a non-homogeneous equation, and to solve this equation, to convert this or to reduce this equation into a homogeneous equation, you need to first check whether the determinant of a, b, f, g, the value of this determinant. So just compare this equation ax plus by plus c and fx plus gy plus d. You can easily understand that a is equal to 1 and here b is equal to 1. From here f is equal to 1 and g is equal to minus 1. So just put these values in this determinant. So you have minus 2, which is not is equal to 0. And so this equation can be reducible into homogeneous equation, and to do this you need to substitute small x is equal to capital X plus h, and small y is equal to capital Y plus k, and you should choose the values of h and k properly, and that will be done here. Okay, so first of all, just substitute the values of small x and capital Y in this expression that is written here, the equation number 1. So dy by dx is equal to x plus h, then y plus k, then plus 3, and after here in the denominator x plus h, then minus this y is here taken here, y minus k, then minus 5. So just to simplify it, x plus y, then h plus k plus 3, and then x minus y plus h minus k and minus 5. This is equation number 2. And as already discussed that this value of h and k should be chosen in such a manner that this term and this term becomes 0. So you can write from here that h plus k plus 3 is equal to 0, and then h minus k minus 5 is equal to 0. Just solve these two equations and you can easily find out from here that h is equal to plus 1. And substitution of h in any one of these equations will provide you k is equal to minus 4. So the values of h is equal to 1 and k is equal to minus 4. So this is the process in which you can choose the value of h and k. Now from this equation, since you have chosen or you have chosen that this value that means this will h plus k plus 3 is equal to 0 and this is equal to 0. So dy by dx now becomes equal to x plus y by x minus y. That is, it is a homogeneous equation. You know that form of homogeneous equation is dy by dx is equal to function of xy. Then here also function of xy. So this is exclusively function of xy. No additional terms like any constant appears here. So this is homogeneous one. And to solve this homogeneous equation, you know the substitution, there should be a substitution, that is y is equal to vx. V is also a function of x. From here dy by dx is equal to v plus x dv by dx. All of these are capital X and capital Y. So now substitute the value of and you know that if you substitute the values of this y and this x by capital Y and capital X, then dy by dx should also provide you capital dy by dx. There is no difficult to understand that. And so this equation then will become that capital dy by capital dx is equal to x plus y by x plus y. Just substitute the values of dy by dx in this equation. So that will provide you v plus x dv by dv by dx, that is equal to x plus vx by x minus vx. So now you need to simplify this equation this expression. So v plus x dv by dx, that is equal to x into 1 plus v by x into 1 minus v. So these x will cancel each other, and this will provide you x dv by dx, that is equal to here from here 1 plus v by 1 minus v, and after simplification you will have x dv by dx is equal to 1 plus v square by 1 minus v square. This v is taken here. Okay, so from here 1 minus v square by 1 plus v square dv is equal to dx by a capital X, and integrate both sides. So you have this is taken here, dx by x is equal to, you can write this term as 1 by 1 plus v square, that is here. So dv by 1 plus v square, then minus 1 minus v by 1 plus v square. Okay, this is here. So you know that this integration will provide you log x, then this is that this will give you tan inverse v minus, and since you know that 1 plus d of 1 plus v square will give you 2v dv. So v dv is equal to half of d1 plus v square. That means this expression is actually, this integration is actually minus half integration d of 1 plus v square by 1 plus v square. So that will give you minus half log 1 plus v square, and this is a constant log c1. So from here you can write a log x plus log, and see, since you can write this as a power of 1 plus v square, so that is equal to, you can write simply that a log 1 plus root over 1 plus v square, then minus this log c1 tan inverse v, or this is the simplification process. Just go through this, and you finally get that x is equal to c1 e to the power tan inverse v by 1 plus v square. Just go through this, all the steps are here given here. So from here x square is equal to c1 square e to the 2 tan inverse v, just squaring both sides, 1 plus v square, and that is from here x square is equal to c1 square is equal to c another constant e to the 2 tan inverse y by, here just substitute the value of v, that was since v is y is equal to vx, so v is equal to y by x. Just substitute the value of v in the form of y and x. Obviously these are of capital X and v, capital X and y. So that will provide you x square is equal to c e to the tan inverse y by x, then x square plus y square, and this x square will go here, and this x square will cancel each other, and from here you can easily write that x square plus y square is equal to c e to the power 2 tan inverse y by x. And now you know that now the time has come to substitute the value of y and x in terms of small x, because you are here to solve for y and x. So that is here you have that, because you substituted x as capital X plus h. So from here you can write capital X is equal to x minus h, and also you know that h is equal to 1. You have calculated it, computed it. So that is equal to x minus 1, and y is equal to y plus k, that is equal to, from here capital Y is equal to y minus k, and you have computed k as minus 4. So that is here. So after that actually you get that x is equal to x minus 1, and y is equal to from here sorry, capital X is equal to this and capital Y is equal to this. Just substitute this in here. So x minus 1 whole square plus y plus 4 whole square is equal to c e to the 2 tan inverse y plus 4 by x minus 1. This is the complete solution. Another one is here, another example is here. Here you have to solve this equation 2x minus 5y plus 3 dx minus 2x plus 4y minus 6 dy is 0 0. So it is not very difficult to understand that this is a non-homogeneous equation. So you need to first reduce it into a homogeneous equation. And just to write this equation, dy by dx is equal to 2x minus 5y plus 3, 2x plus 4y minus 6. This is equation number 1, and you can easily compute from here that the value of a, b, f, g. From here a is 2 and f is minus 5, sorry, b is minus 5, f is plus 2, g is plus 4. That is all written here. So just compute this determinant, that will give you 18, that is not equal to 0. So you can convert it into a homogeneous equation, and to convert it into homogeneous equation, you know the substitutions should be x is equal to capital X plus h, and from here x is equal to, can be written this, and y is equal to this, so capital Y is equal to y minus k. Now substitute these values of small x and y in this equation, and obviously it is not very difficult to understand that this dy by dx is equal to d capital y by d capital X, because these h and k are constants. So here d capital Y by dx is equal to, just substitute the values of small x and small y in this expression that is done here. Okay, so just now it is to simply it is now this equation should be just simplify it, then dy by dx is equal to this 2x minus 5y plus 2h minus 5k plus 3, 2x plus 4y plus 2h plus 4k minus 6. Now we have to choose the values of k and h and k in such a manner that these this term and these terms are separately 0. So that is written here, this is equal to 0, this term, and this term is equal to 0. Just solve this solution, solve these two equations, and you will have h is equal to k and k is equal to h is equal to 1 and k is equal to 1. So both of h and k are 1. So now from equation, this equation you can write, since this term and this terms are 0, so dy by dx is equal to 2x minus 5y, 2x plus 4y. Okay, now substitute, again substitute y is equal to, since this is a homogeneous equation, so you need to substitute now y is equal to vx. Obviously this y and x are capital in uppercase. So dy by dx is equal to v plus x dv by dx. Now just substitute these values in this equation. So this is here, and simplification process is here. Just you go through this, every steps are done here. So no, I think you will have no trouble to understand this. So now from here finally you got x is equal to dv by dx is equal to 2 minus 7b minus 4b square by 2 plus 4b. So from here you can also write a dx by x is equal to, so that will be dx by x, that will be 2 plus 4v, this 2 plus 4v by 2 minus 7v minus 4v square into dv. Okay, just write this expression can be written as 2 plus 4v by 2 minus 8v plus 4v minus 4v square. Just write this as in this fashion. So from here 2 plus 4v by v plus 2 in minus 4 into v plus 2, just v plus, you can write this in this way, this 2 and this v. So here, and this 8v and 4v square is here. So from here dx by x is equal to 2 plus 4v dv by v plus 2 into 1 minus 4v. So from here you can write 2 plus 4v by 2 plus v from here, and from here 4v minus 1. So now integrate this both sides of this expression, dx by x is equal to, you can write the first term 2y 2 plus you can obviously you can write this term as 4 by 3 dv by 4b minus 1 minus 2 by 3 dv by v plus 2. Just simplify this, you will get this equation. So this expression can be written in this fashion. So after that, now just time has come to integrate all the integrations from both sides. So this will provide you dx by x, and this is equal to 4 by 3, and then it will you know that the differentiation of these will give you 1 by 4 dv, so that is 1 by 4. You can write this, and this is minus 2 third, and then this. Okay, just now here this is the process of simplification, and just go through, and and finally you come here that x cube into 4b minus 1 into v plus 2 whole square is equal to c1 cube. Here is a c1 is a c1 was a constant, so that is equal to c the another constant. So from here x cube, then you know that the value of v is equal to y by x, so 4 into y by x minus 1, and here also y by x plus 2 whole square, that is equal to c. Just simplify it. Here is x cube, then 4y minus x by x, and here from y plus 2x by x square. Since it is a squared term, so x square is here, this x and square will cancel with this. So from here 4x y minus x, 2 then 2x plus y whole square is equal to c. Now just substitute the values of small x, that is here, capital X, that is here, and capital Y, that is here. Just substitute this equation, and you finally obtain that 4y minus x minus 3 into y plus 2x minus 3 whole square, that is equal to c. So this is the final solution. Another one is here. See here, you have to solve this equation here. dy by dx is equal to here is this is equal to x plus y minus x plus y by 3x plus 3y. Okay, you have to solve this equation. So first you have to check whether this is homogeneous equation or non-homogeneous equation. So it is easily understand from this equation that x plus y plus 0. So this constant is 0, but here is another constant. So this is a non-homogeneous equation, and you need to first reduce it to homogeneous equation. But the condition, necessary and sufficient condition, is a determinant of a, b, f, g that should not is equal to 0. And from here you can easily understand that a is equal to 1 and b is equal to 1, f is equal to 3, and g is also 3. So this determinant will give you a result, null result. So it is now not possible to reduce this equation into a homogeneous equation by the substitution of this x plus h and y is equal to y plus k. This process will not valid in this case, will not work. So what to do? To do this, you see that from these two expressions, from the numerator and denominator, that if you take 3 as a common term, then this will give you x plus y, 3 into x plus y, and here is also 3 x plus y is term is here. So it is now it will be beneficial if you substitute x plus y by b. So write that here, x plus y is equal to v. So just substitute this, just to differentiate this expression, 1 plus with respect to x, so that will give you 1 plus dy by dx, that is dv by dx. You know that this v should be a function of also a function of x. So that from here dy by dx is equal to dv by dx minus 1. Now just you substitute the values of these values in this expression, or the value of uh, x plus y here. So from this expression you can write dy by dx is equal to minus this is taken as v, so v by this is 3v minus 4. Now you know that dv by dx is equal to dv by dx minus 1, that is equal to minus v by 3v minus 4. So from here dv by dx is equal to minus v 3v minus 4, and this one is here plus 1. So just simplify this. After simplification, here is the simplification process, and you can easily understand that the dx should be b minus 2 by 2 into b minus 1 dv. Just go through this, just practice in your own hand. So dx is equal to, you can write this as b minus 1 by 2 into b minus 1 dv. So this can be written as dx, then half dv minus, then half dv um, by b minus 1. So from here x is equal to half b minus half log b minus 1, that is equal to c1. So now substitute the values of b. Now substitute the value of c. This is a solution, so now you need to substitute the value of c. That is here, you know that b is equal to, what was the substitution? The substitution of x plus b is equal to x plus y is equal to b. So that is here, x is equal to x plus b by 2, sorry, x plus y by 2, because you know that b is equal to x plus y. Minus half log x plus y, b is x plus y minus 1 plus c1. Just this is the substitution process, and these line are the simplification. Just go through this line, and finally we get x minus y plus log x plus y minus 1, that is equal to c. Here 2c is equal to 1. This is a constant, another constant. So this is a solution. Another example is here, c here, dy by dx is equal to cx 6x plus 2y minus 7, then 3x plus y minus 6. So here you easily understand that first you have to check whether it can be reducible into non-homogeneous equation or not. So here you easily understand that a is equal to 6, b is equal to 2, then f is equal to 3, and g is equal to 1. So just write these values in this determinant a, b, then mg, that is 6, 2, 3, 1, that is equal to 0. So this equation can also not be reducible into non-homogeneous equation by the substitution of this small x equal to this and small y equal to this. So next, what to do? We have to employ the methods that we used in this case. So that is also done here. So what is done here? Just substitute this value, because this is the common term. That if you take 3 as common term, then 2x plus y will be there. So this term is common to both. 3x plus y is common to both the numerator and the denominator. So just to substitute this 3x plus y is equal to v, and from here you can find out dy by dx is equal to dv by dx minus 3. Okay, now substitute these values in this expression, that is here. So that will give you dy by dx is equal to 2b minus 7 and then b minus 6, and you know dv by dx is equal, so dy by dx is equal to dv by dx minus 3, that is equal to 2b minus 7 by b minus 6. So just now you have to simplify this expression, and finally you get dx is equal to b minus 6 by 5 into b minus 5 into dv. So after that you need to integrate these equations. So dx is equal to, you can write this as in this fashion: b minus 5 minus 1 by 5 into b minus 6, that is 1 by 5, and they form the first term 1, then from the second term 1 minus b minus 5. So into dv, so just integrate both side. uh, Integrate both side, you will obtain that. So this b minus 5 will give you this one, okay, and the second term 1 by b minus 5 is here. So integrating both sides, dx is equal to 1 by 5 dv minus integration dv by b minus 5. So it is simply you can write from here x is equal to this log b and then log b minus 5 plus c1. Now if you have to substitute the value of v, then you can write, you have to substitute the value of v, here should be v. Substitute the value of v, then substituting the value of v, you have just this 5 is this is at the x is equal to, so from here now substituting the value of v, just you have to substitute the v value of v in this expression, and that will give you this. Just substitute the value of v. Now come to another one. This is the similar form, that is 4x plus 3y plus 6 here, see, and this is 3x plus, no, this is not the similar form, but this is another non-homogeneous equation. So here a is equal to 4, b is equal to 3, and f is equal to 3, and g is equal to 1. Just substitute this, you get the value of this determinant is equal to minus 5, that is not equal to 0. So this substitution, small x is equal to capital X plus h and y is equal to y plus k is possible in this case. So just go through, and the process is utilized here, and just go through this. So if finally from this relation you obtain dy by dx is equal to this, and from here dy by dx is equal to 4x plus 3y, then 4h 3k plus 6 by 3x plus y plus 3h plus k plus 7. So now h and k should be chosen in such a way that this term and this term is equal to 0. These are two equations, and just simplify solve these two equations, you will get the value of h and k. That is done here. So from here h is equal to minus 3 and k is equal to 2. And now from this equation you will obtain dy by dx is equal to 4x plus 3y by 3x plus y. And here now you have to substitute capital Y is equal to Vx, so V is equal to Y by X. So from here dy by dx is equal to V plus X dv by dx, and then from equation 4, that is equation 4 is here, this is equation 4, substitute the value of dy by dx, that is here, and the right hand side is there. So just simplify, the simplification process is here, all the simplification, all the steps are given here. You need to go through this, and finally you get two terms, that is first this term and this term. The first term of the right hand side is here, and this is the integration process, and here you get log b plus 2 by b minus 2 to the 3 by 2, and the right hand side is here. This is the, just you go through this, and this is the right hand form of the right hand side. And now just substitute both these values. Left hand side was log x and right hand side is this, just, and this is the simplification. Just go through the lines. This is the simplification, and you finally got x minus 3 to the power 4. You see into this and this. Now this is the method to solve how a non-homogeneous equation can be converted into a homogeneous equation, and then to solve it. So this is all about this process, and after that we will know how to solve exact differential equation in our next class.